for the introduction, the disc brake inspection, removal and repeating lab study delve into the key aspect of modern vehicle braking systems, emphasizing the importance of understanding how to access, replace and enhance disc brakes for automotive professionals and enthusiasts. This hands-on experience equips participants with essential knowledge and skills, from evaluating wear to maintaining and optimizing brake systems, ensuring safety and performance.
Now we are going to the procedure of disc brake assembly removal. Firstly, we must have a safety first, which is we park on a flat surface, engage the parking brake and wear safety gear. Next, we are going to lift the car by using a jack and secure it with jack stand. After that, we use a lug wrench to take off the wheel. And then we going to the locate and remove caliper mounting bolts with a tool. Gently pry the caliper off if needed. Secure caliper use a wire or a cable tie to hang the caliper, avoid strain on the brake line. And then we must remove the brake pads. After that, we inspect the components, check caliper, brake pads and rotor for wear or damage. For the optional remove rotor, if needed, remove the rotor by taking off any screws or retaining clips. Clean the components by using the brake cleaner. Okay, for the inspection of rotor, we must know that the procedure for the inspection of rotor is same with the dismantle of brake disc, but we will skip the dismantle the brake pad system. We must check the brake pads for wear and tear by the using of brake pad wear gauge to measure the thickness. After that, we must check the brake rotor and then we examine the brake rotor for any damage or uneven wear. And then we check the caliper for the leaks, damage or uneven wear on the caliper. After that, we check the brake fluid level and quality in the receiver. Next, we must reassemble the brake disc system if everything looks good. Torque the wheel nuts to the specific value, and then finally we must take a short test drive to ensure that the proper brake is function.
wanna mess me up. Tripping like I'm Jimmy at Woodstock. Drum me around in your red Ford. Shivers down my spinal cord. Oh, 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 oh. 'Cause you got me holding, holding. Even if I lost all my money, the zero runs deep on it. And I don't need to speak a single word. 'Cause you got me holding, holding. Even if my jokes sound funny, my tongue tied up on it. And I don't need to speak a single word. 'Cause you got me holding, holding. relationships are never meant to last. All the feelings that we shared are in the past. Your relationships are never meant to last. It might take some time, but I'll be alright. I'm moving on, I'm moving on. I know times are tough, but I've had enough. I'm moving on, I'm moving on. Moving on, moving on.
So here are the experiment results. We did an inspection on several parts of the disc brake. First, wear indicator is still in a good condition, but as for the disc brake surface, it's a little bit uneven. As for the brake pad, both still in 70% in a good condition, with outboard thickness is 6.18 mm and inboard thickness is 6.10 mm. As for the piston, it is still in a good condition, but the steel rubber are already in a bad condition, which is it tear. As for the cylinder bore, it's still in a good condition. Here another inspection result. We did the run-out measurement test and we found it is still in a good condition. And here are the disc thickness measurement, which is varies between 22 and 21. And we did the rub test. We found the surface is uneven. As for the guide pin or lock pin straightness, we found it still in a good condition and the lock pin is still straight. Moving on to discussion, what is the condition of the brake pad and should it be replaced with a new one? Based on our finding, the brake pads on both the inboard and outboard sides are in a good condition, suggesting that they can continue to be used without requiring replacement at this time. Next discussion, two causes of rotor thickness variation. As we can see from our result, there's variance between 21 and 22 of the thickness of the rotor. It's maybe because of the overheating. The excessive heat produced during extended or intense braking can induce thermal stress and uneven cooling, ultimately leading to rotor warping. Secondly, rust or corrosion on the rotor surface can also play a role in uneven wear, impacting the rotor thickness. So here are several steps or procedure we need to do to repair the thickness variation of the rotor. First, we did the inspection. We check the brake pad or rotor to know whether both are in good or bad condition. Next, we measure the brake pad's thickness using vernier caliper to indicate which section is worn. Then we measure the thickness of the rotor disc using micrometer to obtain more specific readings. Next, we did the replacement rotor. After the thickness data rotor are obtained, if the rotor thickness is below the minimum allowable thickness or if resurfacing would compromise the structural integrity, replacement is recommended. Next, we did the replacement brake pad. If we want to replace a new rotor, we also need to replace new brake pad because we want to know whether the rotor is still having the same problem or not. Then we did the wheel installation, ensuring proper and even torque when installing wheels to prevent uneven pressure on the rotor. Lastly, we conduct a test drive to verify that the braking system operates smoothly and without any unusual noises or vibration. Moving on to discussion number 3, the understanding about run-out measurement test. Run-out measurement test is essential for verifying the presence of markings on the brake pad, serving as an indicator of the pad's condition. These markings play a crucial role in assessing the overall health of the brake pad. Maintaining the integrity of these markings is vital, as any deterioration could lead insufficient brake performance that may lead to braking errors, especially during emergency stops or challenging driving conditions, or undesirable incidents with our braking system if the brake pads are not in optimal condition. As for the last discussion, what is our finding for the guide pin or lock pin straightness check? What can happen to our disc brake system if the guide pin or lock pin is not straight? In our lab session findings, the lock pin straightness is still good and in straight condition. If the guide pin or lock pin in disc brake system is not properly aligned or is otherwise impaired, it can result in a range of issues that negatively impact the brake system's performance. Initially, a misaligned guide pin may cause the caliper to exert constant pressure on the rotor, even after releasing the brake pedal, leading to brake drag. This can subsequently result in increased fuel consumption, overheating, and premature wear of brake components. Additionally, misaligned guide pin may contribute to vibration and noise during braking, creating an uncomfortable driving experience and potentially indicating a problem within the brake system.
In a nutshell, disc brake use a metal rotor or disc with flat line parts that are replaced in the brake caliper. The hydraulic pressure generated by the piston inside the caliper is crucial to force the brake pads against the rotating disc, creating frictions and facilitating the braking process. To ensure driver safety, regular brake maintenance or inspections following the manufacturer's recommended maintenance schedule and seeking professional help with brake-related issues are important parts of responsible vehicle ownership. Brake systems are critical to vehicle safety, and a proactive approach to their maintenance contributes significantly to overall road safety. So, in the lab session, we learned a lot about how this brake works compared to drum brake mechanism, how to assemble and disassemble the brake system, and we also did some tests or inspections such as the friction test on the disc surface, learn about the wear indicator or wear gauge, and check the thickness of the disc. During this inspection, we learned that this is additional information for us to understand the importance of maintaining the braking force in its optimal condition, whether during normal or emergency braking.